Alright, we've got a rhombus video. We're going to do a couple of things with a rhombus. As you remember, a rhombus, by looking at the tick marks, will have equal length sides all the way around. As you can see by this rhombus, it may not be drawn to scale, but that really doesn't matter at this point. What we need to focus on is I'm going to try to find angle B or angle ABC. Angle ABC. B being the vertex of this angle, and that's what I'm going to find. If I take a look at this and I know anything, a rhombus kind of has the same properties as a parallelogram in the sense that whatever I have here as an angle, I will have here as an angle. And whatever I have here as an angle, I shall have here as an angle. Now, two ways to do this. There's the easy or the easier way. I'm going to first go the easy route. A rhombus, as you know, has a total of
360 degrees.
360 degrees. Since I know that angle C and angle A are going to be congruent, I can go ahead and write that I have 83 degrees up here for angle A. Knowing this, I have 83 degrees. I have two of them, so 83 times 2 will give me a grand total of 166 degrees. I now have angle D and angle B. I'm going to subtract my 166 from the 360. I am going to subtract, borrow when I need to. I have 194 degrees left over. Because B and D are congruent, they are equal, I can divide now by 2. Knowing this, 2 into 19 would be 9. Let me go ahead and show you down here. But by this point in the school year, most of us are doing a lot of this in our head, but it doesn't hurt to work it out all the way. I now see that each one of these will be a 97 degrees. Now I need to look at my original question. Angle B or angle ABC should be 97 degrees. Now, the other way I could have done this, making it even easier.
Kids daycare. All students with kids are kids. Just come to the front.
If you need to excuse yourself for kids, go ahead. Here's the other way that some kids like to do this. They know that I have this straight line, and if I've got two angles here that are going to be different, I have 83, and I'm going to subtract from 180. And guess what? It works out perfectly to 97 degrees. Now, let's move on to our second one. I have a larger rhombus. It is rhombus ABCD, but I have actually have a triangle AED or ADE or EDA. However you want to do it, it's all the same. I see that I have 105 degrees. I have 50 degrees. They're asking me what is angle ADE. So I'm looking for angle D. Some of my kids get confused and they say, well, I see angle D. It's already 50 degrees. But we have to look at its angle ADE. So I'm actually looking for this angle that's in red here. A couple ways to do this. You can do it the easy way or the easier way. I'll start with the easier way. As I go across and I see things like this, once again, I see that this angle and this angle will be the same. This angle and this angle will be the same. So A angle and C angle will be the same, and B and D will be the same. I'm going to go the easy way first. I'm going to remember that a straight line has 180 degrees. I have two different entities here, a obtuse angle and probably an acute angle. I have 180 degrees. So far I have 105 and 50, which would leave me 155 degrees thus far. I'm going to go ahead and subtract as we've done all along, and I'm going to end up with 25 degrees right here, 25 degrees for angle ADE. Now that is one way that is somewhat easy. Another way I could attempt to solve this problem is by looking at my triangle. I see that I have 105 degrees for C, so I need to know that I have 105 degrees for angle A. I also notice that I have a 50 degree here, and knowing what we've learned thus far, an interior angle opposite should have the same degree angle of 50 degrees. Which would leave me finding this angle. 105 degrees plus my 50 degrees, which would be up top, would give me 155 degrees. And Miss Pickens, a triangle has
180 degrees.
180 degrees. I'm going to subtract what I have, 155, and lo and behold,
Wow.
once again, 25 degrees.